So, Saji, our next session is by Sindhu Chandran, and she's going to talk about migrating Apache Flink data pipelines to write to Azure Cosmos DB Cassandra API.
Okay, I think she's going to talk us through the changes needed and the best practices that she learned during the migration to Azure Cosmos DB Cassandra API. To introduce her, Sindhu is a data science and engineering manager at IBM. Her job involves helping other people realize the value from data, and I'm super excited to learn more about her migration story to Cosmos DB Cassandra API. Over to you, Sindhu.
Hi, everyone. Thank you for having me here today. So on myself, I'm Sindhu. I work with IBM Consulting. I work with customers mostly on data engineering, and I also dabble in data science for fun. And today I'm going to be talking about some experience that I recently had migrating Apache Flink pipelines, which were using Cassandra on-premise to Cosmos DB Cassandra API. So to give some context to what I'm going to talk about, this is a fictitious company called Kirana Cube. Kirana stands for your neighborhood store, community store, and this is also again a customer 360 kind of use case where they get data from multiple data sources, internal and external sources, batch and streaming data sources, and they have a need to make it available to their digital channels to provide an enhanced customer experience. And now Kirana Cube is on their journey to cloud, where they are invested in Azure cloud, and they would like to continue using their technology stack, which they have considerable investment on already, which is based on Apache Flink, Kafka, and Cassandra. So this they expect this to continue providing the same throughput and latency that they currently enjoy on their on-prem setup. So this is where the context is, and I will be talking mostly from a developer perspective as to what we need to be aware when we move from Apache Cassandra on-prem to Cosmos DB Cassandra API. So as you're probably aware, Cosmos DB is available in these different flavors. And one good thing for K2 or Kirana Cube is that they can continue using their Cassandra investment with hopefully minimal changes. The great thing is that it is via protocol compatible with Apache Cassandra. It is available as a fully managed platform as a service. So this means that they no longer need to manage the nodes, clusters, what they were doing currently on-prem. So this saves considerable amount of time and money. And the third important advantage is that they can continue to use the client drivers and the familiar CQL that they were using on-prem. So this is the kind of setup that they are moving to, where they will continue to use their Flink and Kafka based data pipelines hosted on Azure Kubernetes service and writing to Apache Cassandra provided on Cosmos DB. From where the online application will read this data based on the requirements of the digital channels that this empowers. So this is my 10-point list of some of the things that I have learned during this journey. So, this is like mostly from a developer perspective, but covers some part of the architectural concepts that we need to be aware of when moving from Cassandra to Cosmos DB. So the first one is to know your DB, then you get going with tools. Then the next third step is about understanding the connector APIs and SSL setup needed. And very important, the dealing with request units for capacity. And then making use of insights to understand what is really happening there. Optimization and error handling. And then making use of partitioning well. Managing consistency, availability, and finally planning your data migration from on-prem to Azure Cosmos DB. So the first important item that you need to be aware of is the resource model. So this is the mapping to Cassandra for your Azure Cosmos DB. So you have this database account or the Azure Cosmos DB account created based on the flavor of Cosmos DB that you are using. So you create this for Cassandra, and the database here that you create maps to the Cassandra key space. And within the database, you can add multiple containers, and container is the term which maps to Cassandra table. And the items here map to Cassandra rows. So this is the first important part to understand. And the next thing to understand is about what is supported and what is different, because you might spend a lot of time otherwise, finding issues or trying to debug things which you think might work, but it is actually not supported. And there are also a lot of advantages which come with Cosmos DB in terms of the increased replication that it provides and things like that. So it is very important that we first review what is supported and different so that we are not wasting time, later deciding that what is not supported will not work. We cannot live with what is not supported, or making sure that we know of the advantages that Cosmos DB provides. So these are the first two steps that I would start with to know your DB or know your Cassandra DB on Cosmos. And the next step would be to get going with the tooling. And here again, when you were on-prem, probably the SQL just came along and you might not have really bothered setting this up. And currently the Azure portal does not really provide the complete SQL tooling on portal. So it is very important that you have follow the instructions and the versions which is supported for SQL, and set this up on whichever OS where you want to work with, and make sure that you use the SSL settings as applicable, and use the SSL parameter while connecting. So this would be the second step to start with to get your tooling set up for Cassandra. Okay, and this is where I think as a developer, you would probably spend some time on, because there are some differences here that might be needed, some changes which might be needed to your code to make sure things work seamlessly. And but very nicely, when we have a lot of examples available here already. So the first thing to start with that I would do is take one of the sample applications which are provided to validate your connectivity in the Azure environment. So you could use the Java, .NET, Python, or Golang packages. And in my story, K2 or Kirana Cube decides to go with Java v3. So this is the one that you download, and you can try to connect using this sample application to confirm everything is good on your Azure environment. So that is the first step. And as I said, there are these multiple options that DataStax Java drivers have in terms of v3 versus v4. And Apache Flink, again, supports multiple programming languages. So it supports Java, Scala, Python, and SQL. And in the case of Kirana Cube, they were primarily on a Java stack, and they already use this particular Cassandra sync or a connector that comes with Apache Flink called Flink Connector Cassandra. So it is very important to be aware that this internally uses the DataStax version 3 API. So when we use anything related to Cassandra, it is better to stick to the same. If you're going to use the Cassandra sync, that is one option. Then you would rather use the same compatible Java drivers, the version 3 of the Java drivers. And in case you want to go for Java version 4, you could implement a custom connector. So this is also a good option in case your code base is in Scala, or you want to use the version 4 for some advantages. Then you could create a custom Cassandra connector with the version 4 API. And Azure provides some additional extensions for Cosmos DB connection handling and retry logic, which is available in both the version 3 and version 4 APIs. The last thing to know in terms of code changes is related to the SSL connectivity. So you might not have been using this on-prem if you were, in a internal environment, and so this is something that has to be done when we move to Azure. So you could use just the with SSL without a key store, and it would just pick up the default Java trust store, which would do for dev environments. But otherwise, you can use either the SSL options with Java v3 API or the SSL context with the version 4 API. So these are the options for SSL that has to be set up while connecting to Cassandra. So this sort of summarizes the key changes that are needed from a code point of view for your application to work. The next important lesson is about dealing with request units or RUs for capacity. So a request unit is defined similarly across all APIs supported by Cosmos. So it is the cost of the database operations expressed as a performance currency. So it abstracts the usage of these different CPU, IOPS, and memory. And you have to be aware that there are these different modes of setting up this which are available. So if you do not really want to be dealing with RUs, then you could use the serverless option, but you pay based on usage. You don't need to manage RUs here, but then there are some limitations in terms of the size of data and also the geo redundancy options which are available. The next option is the provision throughput or manually managing your RUs. This can be done at the container or key space level or at the database the table level. So when you do it at the key space level, it works for smaller tables, and there is a limitation of 25 tables, and you might not have visibility into hot tables which are causing hot partitions when you do that. The database level, the table level gives more flexibility in managing your RUs. The provision throughput is a good option if your workloads are predictable with maybe some 20 to 25% variation. And the other option is the auto scale, which again you can set at a container or database level. So where you pay 1.5 times the cost of the provision throughput, but then there is the option to scale between a range that is set. So one option would be to start with auto scale to avoid any limitations of lesser RUs, and then based on your usage, you could provision throughput to better manage your cost. And this is one of my favorite parts of moving to Cosmos DB Cassandra API. So there is this beautiful drill down analysis of all the database operations. So you could go and check with time range at a table level. You could get throughput requests, partitioning details. So a lot of insights which are available, which you can further customize as well if you want specific metrics. So this is like a very useful feature that is a must to leverage when we move to Cosmos DB Cassandra. And this is again very important to know. So one of the first things that you face when you probably move is the rate limiting issues. So in the case of Kirana Q, the jobs were failing because of lesser RUs, and you don't really want your jobs failing because of it. So you could just so there are two options. You could increase the RUs based on the latency expectations, and even if the RUs per second becomes a little less than what is provisioned, you really do not want your job to fail. So it is advised that you implement the Cosmos retry policy, which is a custom version of the Cassandra retry policy. So this is available on the as an open source GitHub project. So there is a Cosmos retry policy that is good to use to avoid these rate limiting errors. And this is again a must do to implement the reconnection policy. And Cassandra supports some 2 or 3 reconnection policies. The one that is recommended for Azure Cosmos DB is the constant reconnection policy with around 2000 milliseconds. So this is the option, and this is sort of a must have, because we found that without this, your jobs are likely to have connection issues. And so, as I said, there is this Azure Cosmos Cassandra extensions for Java, which has these additional settings and tuned settings which you can use, like the Cosmos retry policy. So this is also a good tool to use to better manage your connectivity settings. And finally, what we learned is that you get charged the same if your record is 0.1 KB or 1 KB. So it helps to sort of have a data model which is suitable to that, and important to analyze the read, write, and query volumes so that we can manage the throughput, provision RUs, elastically scale, do all of those. Coming to partitioning, if you have been on Cassandra, you must be already using the Cassandra partitioning for improved queries. So on Azure, there is a concept of a physical partition, which is the equivalent of your VM or compute unit, and it can have up to 10,000 RUs. There are 4 replicas of the partition created. Be aware that if you need more than one partition allocated, then you need to set your RUs to more than 10,000. So especially if you are having Flink-like parallel distributed programs where you want to be writing in parallel, or you want to be loading data maybe quickly or with a higher latency, and you might want to be aware that you need to provision more than 10,000 RUs if you need to have more than one partition. And the logical partition is the equivalent of the Cassandra partition, and the insights lets you monitor hot partitions. For example, if I had a table which is based on location, which had a partition based, a column based on location, and let us say 80% of the customers happen to be from Mumbai, then it would cause a hot partition, and that might not be the ideal partition key to use. But it lets you, the insights lets you catch these issues as well. So this is about partitioning. And again, you need to be aware of how the consistency maps to a Cassandra consistency and the cost implications of the same. So if you, so there are these different options which are provided on Cosmos DB, and there is a mapping provided from how this kind of relates to the Cassandra level consistencies. So it is important to be aware of this in choosing your settings. And a plan, when it comes to availability, the node outages seem very well covered because there is a guaranteed 3 replicas which are kept in each Azure region. So the node outages are covered that way. And to cover zone outages, there is an option to deploy across availability zones when you create the Cosmos DB account. And when you deploy more than one region, you can have a highly available application, and you could be writing in one region. So this is the option that Kirana Q opts for, which is like single write region. So you write to one region, but the read is available from more than one region. So this is a good option to provide high availability and low latency. But in case you have a lot of write which is needed from multiple regions, this is supported as well, though with some possibility of conflicts which you have to manage. For each Azure region, there are 4 replicas of the data which are made available. So based on the number of regions, there are so many more copies of the data which is going to be kept for availability. Finally, on data migration, so you can continue to use the CQL-SH copy command for smaller data sets. And Azure, the documentation recommends Spark for larger data sets, but since K2 or Kirana Cube is a Flink shop, we used Flink instead, and this works well too. So this is on data migration. Some references. So the Azure documentation is extremely helpful, and the tech support were very helpful in helping us understand a lot of the changes and concepts, what is supported, and making sense of the RU concept, which was particularly new when moving from Cassandra to Cosmos DB. Thank you for having me here today.
Thanks so much, Sindhu. That was really great. Tell us about a couple of issues that you didn't have to bother about anymore after you migrated from Cosmos DB as compared to your earlier self-hosted setup.
Can you repeat that question? I think I missed a part of it.
My question, Sindhu, was can you tell us a few benefits that you saw after migrating to Cosmos DB? That hey, maybe this thing I didn't have to bother about anymore.
Okay.
Yeah.
Yeah, all right. One thing is, of course, that I am not really aware of all the 25 nodes and the OS patching, that you get notified of every quarter. So we don't really need to be aware of that. That's number one. So all of that happens seamlessly behind the scenes. The second one is the insights. So I think that's like very, very useful to have that freely available for use to monitor what has happened and to monitor the throughput, the latency and partitions and all of that to optimize. So those are the two things I think which I particularly benefited from.
Okay,
Awesome.
adding to the question that Sweta asked, you spoke about 10 important things on the reasons on why you choose Cosmos DB Cassandra API. On the other side, we also have this Cassandra managed instance offering as well, right? Were you comparing those two before making this decision for this data pipeline use case?
In this case, not really. So this was not a decision which I made. So it was sort of, part of the strategy that the organization had. Yeah. So.
All right, got it. Okay.
So, thanks for hitting on some of the important points about migration planning there. One of the things you mentioned was, about the partition key selection and being wise with partitioning, right? So what were your learnings around data modeling? Since you were migrating, I'm assuming, there might have been fewer changes, but did you have to tweak anything with the partition key selection? How did you go about that?
Not yet, I would say, though we are kind of watching it. So we have a bit of a combination where we do have like some workload on-prem, but which isn't a whole lot. So we are also having a lot of new requirements where we are adding, to our data model and building for new requirements. So, and currently it's like mostly for new requirements that we are going to be building. So we are, I would say, watching it closely. So yeah, that's where it is.
Okay,
Sure.
I think you spoke about, I think you spoke about different scenarios where you have implemented the retry logic. You mentioned about a reconnection policy with, 2000 seconds or milliseconds, I would say. Is it particular to your scenario, or is there any recommended practice that you recommend others when they're doing this kind of migration?
In this case, this is something that I followed based on the documentation. Yeah, right. So because on-prem, we did not really use this particular parameter. So that was definitely a change. But this is the recommended setting. So there are two or three reconnection policies that are provided by Cassandra, but this was particularly recommended in the documentation.
All right. I think you answered most of all the questions we had. Thank you, Sindhu, for sharing your insights, especially around one of the hottest topic these days for customers. Yeah, we usually hear from customers that migrations can be sometimes tricky because you have to make sure that business continuity is always there and the whole solution works in the expected manner. Sweta, I think Sindhu mentioned about some of the things that beginners need to consider when they are starting with some of the PaaS services, especially on Cosmos DB. What's your thoughts?
Right. Right, Saji. So yeah, like we hear often, right? When you're new to Cosmos DB, there are certain concepts that you might need to wrap your head around before your life becomes much easier, right? Because it's a scalable service, unlike your self-hosted instance. So things like partitioning, data modeling, the insights, all of that Sindhu has covered today. Thanks again, Sindhu, for sharing your experience and your pain points and insights on how you got past those challenges and leveraged Cosmos DB Cassandra API. So thanks so much again. It was great to have you here.
Thank you.